Another wow video, and there's several for this particular line. It's part 284C3K29C, line 22f1fa19c3k29c, Octupole pulse magnet, Antimatter, Betatron motion Wow Seti. So there's the alien radio signal there, and this is a pulsed octupole magnet picture that I found. It's a bending magnet, quadruple magnet, ejection, undulator, multipolar wiggler, vertical wiggler, ring present lattice. So it's kind of cool. Development of a pulsed octupole magnet system for studying the dynamics of transverse beam instabilities in electron storage rings. Hey, transverse beams. I wonder if you can use that with that new design that I gave you. Interesting, eh? You never know. CERN has to take a look at this. So Tsukasa Majama, Yukari Kobashi, and Shinya Nahashi. This is from Tabuska Ibakari, Japan. And it's daxdoi.org, okay? So their abstract says, in order to study the dynamics, this is a PDF file, so it's somebody's study. In order to study the dynamics of transverse beam instabilities, a pulsed octupole magnet system was developed in the Photon Factory electron storage ring. The system consists of an octupole magnet, a pulsed power supply, and a ceramic chamber. The system was designed so that the integrated field of the magnet could be excited up to 2,550 T m squared, with a rising time of about 1.2 ms. Before installation of the magnet into the ring, a field measurement was carried out to examine the performance of the system. Through the measurement, it was confirmed that the magnet satisfied the design values. After the installation of the magnet in the PF ring, in order to confirm the effect of the system on an actual electron beam, preliminary measurement of the vertical instability was performed. The measurement results showed that the growth process of the instability can be measured using the system, and in the growth process, the system can measure the dependence of the instability of the bunch current and the number of the filled buckets. So it's Betatron motion, transverse instability, amplitude-dependent. That's sciencedirect.com. I found that. Next, so I googled the Betatron motion to find out what it is, and there's another PDF that comes up. Betatron motion with coupling of horizontal and vertical degrees of freedom from VA Lebedev and S.A. Bogacz from July 2012. So this is brand new. Jefferson Lab, Fermilab. Presently, there are two most frequently used parameterizations of linear. Remember we were talking about linear elasticity? Keeps coming up in the videos. XY coupled motion used in the accelerator physics. They are the Edwards-Tang and Ripken parameterizations. The article is devoted to analysis of close relationship between two representations, thus adding a clarity to their physical meaning. It also discusses the relationship between the eigenvectors, the beta functions, second-order moments, and the bilinear form representing the particle epsiloid in the 4D phase space. Then it considers a further development of Mays-Ripken parameterization, where the particle motion is described by 10 parameters, 4 beta functions, 4 alpha functions, and 2 Betatron phase advances. In comparison with Edwards-Tang parameterization, the chosen parameterization has an advantage that it works equally well for analysis of coupled Betatron motion in circular accelerators and in transfer lines. Considered relationship between second-order moments, eigenvectors, and beta functions can be useful in interpreting tracking results in experimental data. As an example, the developed formalism is applied to the FNAL electron cooler and Derbenev's vertex-to-plane adapter. Accelerator physics, Fermilab, Pub 1033 AD, and it's rx.org. Okay, so I'm going to Google Derbenev's vertex-to-plane adapter to find out what I find. And during my thoughts, I find Electron-Ion Collider is the keyword that comes up with the PDF files. So I'm going to Google the keyword Electron-Ion Collider, and these diagrams come up. So it shows a down quark, proton, up quark, gluons, and up quark. Okay. So these fundamental particles carry a strong nuclear force which acts as a kind of subatomic glue binding quarks together. So www.bnl.gov. And then I found this The Electron-Ion Collider embodies a vision of our field for reaching the next QCD frontier, the study of the glue which binds all atomic nuclei. Oh. So they talk mu, EIC detector, E cooling, RHIC, ERHIC, energy recovering Liniac, 3.9 GeV pass, Phoenix star, 5 GeV, E plus storage ring, 4 E beam passes, low energy beam pass. See, my design has the two circles going, like you've got them going two different directions here as well, but these two circles, there's something a little bit different there. So www.bnl.gov. So the next set of videos actually show the new design that you're supposed to do with this thing you want to build. The best way to do it, to get the fastest speeds with it. Okay, so stay tuned. There's several videos for it, okay? Thanks for watching.